Hi everyone. So we will continue with 5.3 solid. At the end of the lesson, you should be able to state the properties of solid, explain the process of freezing, melting, sublimation, and deposition, differentiate between amorphous and crystalline solid. Next, state the following type of crystalline solid with appropriate example of each: metallic, ionic molecular covalent, and giant covalent structure. Now let's look at properties of solid. So for solid, the particles you can see they are arranged closely together as you can see in this diagram. So the particles can only vibrate and rotate at fixed position. They have rigid arrangement, and due to the small space between them, it is only a small space between each of the particle, therefore it unable to move freely. It has definite shape and volume. It also has strong intermolecular forces between each of the particles that hold them into a fixed position. It has high densities, and solid are incompressible compared to gas and liquid. Let's have a look at freezing process. It is a liquid change into solid. When the temperature of liquid is lowered, the kinetic energy of the liquid particles will decrease. So remember, when you lower down the temperature, what happened to kinetic energy? It will also be lowered. That is why the liquid particles will vibrate at slower rate until a point is reached when the intermolecular forces are strong enough to hold each of the particles together in a fixed and orderly arrangement. That is when the liquid freezes and it forms solid. So in this case, you can see water in liquid state of liquid. When you cool down the water, you will lower down the kinetic energy of the particles inside here until the intermolecular forces between the particles will hold each of the particles together and rearrange themselves in a fixed and orderly arrangement. That is when you have the solid state. Next, we will look at melting process. So melting process is the reverse process from freezing. It is when you give heat, let's say you give heat to solid, in this case ice, means you increase the temperature. What happened to the kinetic energy? It will also increase, means the molecule or particle will vibrate faster and more energetic. At its melting point, the particle will possess enough energy to overcome the attractive forces or intermolecular forces between them. Therefore, all the particles will slowly be able to move freely, and then solid will change to liquid. Next, we will look at sublimation process. So sublimation process is when you have solid phase and it convert directly into gas and without going through liquid phase. An increase in the temperature will cause the kinetic energy of the particle will also increase. So this allows the particle to overcome the intermolecular forces and become mobile, so it can freely move around. As the particle escape the solid state, it will disperse as gas. So that is why we call it as sublimation. So the key here is you need to remember when you increase the temperature, kinetic energy will also increase. When you have higher kinetic energy means the particles can overcome the intermolecular forces that bind them together. Therefore, they can move around more freely. Next is deposition process. So deposition is the opposite process from sublimation. So you can see here deposition is when you have gas change into solid without going through the liquid phase. And in this case, it happens when you lower down the temperature. What happened to the kinetic energy? It will also be lowered. And this caused the particles could not overcome the intermolecular forces that bind between each molecule, and they will become rigid. Particles will start to stick together to one another, and they will change to solid. Next, we will look into types of solid. First, we have crystalline solid. So it is when atoms, ion, or the molecule are arranged in regular repeating unit, or we can say it in orderly arrangement, maksudnya di dalam keadaan yang tersusun. So each atoms, ion, or molecules, they will occupy specific position. It is formed when you have saturated liquid that is cooled down slowly. So maksudnya the atoms or ions or molecule will have more time to rearrange themselves in orderly, regular, repeating arrangement. And for example, untuk crystalline solids, there are ice, sugar, salt, diamond, and you can see in this diagram you have quartz. Okay, silicon dioxide, but in form of quartz. So you can see it has regular repeating or arranged in orderly arrangement. So dia keadaan yang tersusun dan berulang-ulang. And this causes them to have high melting point. Alright, so let's have a look at amorphous solid. So for amorphous solid, they have no orderly structure. And how does this form? It is formed when you have your saturated liquid that is cooled rapidly. So means the atoms or ions or molecules do not have much time to arrange themselves in orderly manner. So dia punya arrangement is random or not in order lah. For example, glass, plastic material and charcoal. And that is why untuk amorphous solid, it is a little bit brittle, rapuh, and biasanya melting point dia agak rendah. For crystalline solid, it can be divided into four. First, we will look into metallic solid, metal. So, untuk metal, they are closely packed structure and it composed of atoms of the same metal linked together by metallic bond. All the metallic elements such as sodium, magnesium, ferrum, and so on, they are arranged like this. So this is the example. You have sodium ion that are closely packed structure and it is held together by metallic bond. So how can we show this? We can show it by the C of delocalized electron. So you have, in this case, you have Ag plus ion, silver ion with an electron. So you must show your drawing of C of delocalized electron, where you have your ion, in this case Ag+, and it will has electron around the silver ion or any metallic ion. And make sure if you were asked to draw, make sure you label the positive ion and label the electrons. Next, we will look into ionic solid. So ionic solid, it consists of cation and anion, positive ion and negative ions, that are held together by ionic bonds. So for example, you have NaCl. So NaCl is a formation from Na plus ion and Cl minus ion that are held together by ionic bond. So you can see this is the structure. So the NaCl structure is arranged in orderly manner. Okay. Next, we will look into molecular covalent solid. So it is composed of molecules that held by intermolecular forces such as van der Waals forces or hydrogen bonds. So for example, oxygen gas, H2O water molecule, iodine, ammonia, and so on. So you can see this example. Let's say this is H2O molecule, water molecule, and between one water molecule with another water molecule, so this is one water molecule, this is another water molecule, so between them there is hydrogen bond. So this is what we call as molecular covalent solid. So let's have a look at giant covalent solid. It is a large molecule that composed of atoms linked together by covalent bond. For example, diamond, graphite, and SiO2, silicon dioxide, quartz.